Hello everyone, this is a video lecture for Calculus 3, section 13.1, parametric equations. So there's not a whole lot to talk about beforehand. I don't have like formulas for you right now, but I do want to just start jumping into some problems from the homework that I thought were really good. So let's start with 13.1.003. So first off they say, hey, find the limit as t goes to 0 of, and then they give me this vector here, e to the negative 5t, t squared over sine squared of t, and then finally sine of 2t. Now, I think on the homework that they use the IJKs and all that. Either way, really, it's not a big deal. What you do if you have a limit is at least you try to plug it in and see what happens. So we got e to the 0. Here we got 0 over 0. And then we got basically just a 0. So that's actually not too bad. What this ends up being then is for sure this is a 1. I don't really know the next one. And then we got a 0. So this is so far what I'm thinking. Notice though, if you get a limit and it goes to 0 over 0, you're going to use L'Hopital's rule. So how does that work with L'Hopital's? I'm going to take this and find its derivative, and then take the limit again. So derivative top and bottom separately, I got 2t in the top and the bottom. That 2 is going to come down, leaving a sine t to the 1 power, but then chain rule, what's derivative of sine is a cosine here. Okay, and so then I, again, try to apply that limit, going to 0. I would get 0 over 0 again. So now I take this and I try to find its derivative again. One particular thing to note is that you could rewrite this denominator as 2... No, hold on. It's sine of 2t in the denominator. And so it's so much easier to do that derivative. So let me just start with the original that we would work with. And so now I want to take the derivative of that. So then 2 in the top, and then sine would go to cosine, but that 2, again, chain rule will come to the front now. So it should look like this. Now when I apply that limit, going to 0, you would get, let me just write it out, I guess. You would get 2 for sure in the top, and then you actually get cosine of 0 is going to be 1, so 2 over 2 makes a 1 right there. And thus, my final answer is 1, 1, 0. There you go. Keep cruising. So we got a 13.1.007. So I have an r of t. This is a function, a parametric, I guess, line or graph of sine 6t, comma t. And I think they're going to want me to graph it. I'm looking at my my work here, and I see that I put a graph here, and there's nothing really else going on. So let's graph it. This is how I see it. I see that this is an x and this is a y. So then I got x is equal to this sine of 6t, and then y is equal to t. I could basically just plug this in right here, so that I guess in a way x is equal to sine of 6y. And now I've went from parametric mode to rectangular mode. This is rectangular, although it doesn't seem like it because they're all flipped. So this is how I understand it. Let me graph this as if I had a y and an x here. I'm just changing my axes so it's easier to see. Well, then just graph sine of 6x or sine of 6t or sine of 6y or whatever you want to do. Well, basically, it's just going to, be a sine wave. And so how do I translate that over to a true x and y? Is that I simply just follow it going this way. Now notice that we're going into quadrant 1 here. Okay, we're going to positive y, positive x. So it's probably going to do this. See how I'm, again, starting going towards quadrant 1 from the origin. So this is my answer. Also notice my arrows here are important. The reason why is because if you go back, as t increases, your y increases. So as t gets bigger, your y will also get bigger. You're going up, essentially. Or you could just use a parametric mode in your calculator. That might be easier. So I wanted to just show that one because now we're going to be doing 3D versions. So 15 now. R of t is equal to t squared, t to the fourth, t to the sixth. And they want to graph this one. And of course, because it's 3D, it's going to be on something kind of like this here. Well, let me explain how I think this one is. I don't think plugging it in would help so much as what you're thinking. What I'm going to say is, this is how I'm going to rewrite it. This is funny. This is increasing. This is increasing. And then this one right here is increasing. Like, think about it. T squared, that's like, it's going up. T to the fourth is going up. And t to the sixth is going up. I mean, it's near vertical. This thing is like really, really quickly going up. But notice that this will stay positive, positive, positive. Everything's positive here. So as you go, as t goes towards infinity, as you're going bigger and bigger t's, well, all of these are going to go big. Not necessarily you don't need to go to infinity, but I'm saying they're all going bigger and bigger, bigger, positive, positive, positive. So let me just draw this the best I can here. I'm going to use a different color. That way it makes it look cool. Whoosh, there you go. It's not perfect, but essentially what's going on is here in the XY plane in particular, this part right here, it probably looks a little bit like that. And so, but it's coming up towards us also. I can't show that here, but it's coming up towards us. So it's also increasing here, but it's also going this way. So its shadow down here is probably like that, but then it's going up a lot. Cool? Okay. Again, it's probably better to like rotate this stuff sometimes. This one's not too bad, but others here in a minute, I'm gonna draw it multiple times in an effect to show a rotation, so you can see it from different angles. So I got my R here is equal to t sine of t 3 cosine of t. Awesome. So how I see these are, I'm looking for particular shapes. This one right here is linearly increasing. So as t increases, x will also be increasing linearly though. So it's going to be just, if t is going more, then x is going more. Just a direct comparison to one another, okay? Just keep that in mind as we keep going. Here, these actually couple together to make an ellipse in particular. I would say circle generally, but because you can see that the amplitude here of that one is 3, I'm going to definitely have to say ellipse. But how this works is that, like, let's go back to pre-calculus. We got x equals r cosine theta, y equals r sine theta. Well, this right here, what does this make? It makes a unit circle. I probably should have graphed it like this. There you go. It makes a unit circle counterclockwise, starting from the x-axis and going around, right? At radius r in particular. So same thing here, but notice that my z is a cosine and my y is a sine. So it's going to make it a little different. So if I'm going to do y and z axes, like this is my yz plane, it's actually that z, it's flipped. See, like my, I guess you could say your independent variable, your dependent variable, that kind of thing. Your x and y axes normally, this is normally x and y right here. Well, it's that my z is a cosine instead. So they're saying cosine for this guy, but sine for this one. It's flipped, if you can notice. Normally, it should be that it's cosine and then a sine. So how does that even work? How am I supposed to graph this then? Well, instead of starting at the x-axis and going counterclockwise, you're starting at the top here, and you're going clockwise. Ooh, there we go, clockwise. And of course, this is very rough. Notice it's an ellipse, right? And it's 3 amplitude on the z's. So not technically this one, but really it's probably more like this. Again, going up to 3 and to -3 essentially. And here would only be a 1 and, well, -1. But that's not to scale. Okay, so there you go. This is now the YZ plane. And again, my x is increasing linearly. I want to graph the whole thing together. What does it look like? X, Y, and Z. See the YZ plane right here? See that YZ plane? So what I'm going to say is, oh, it looks like an ellipse again here, and we're going clockwise, and we're going back this way, right? So that's what I want to say the graph is, but I'm increasing my x as I move along. The more t I have, the more x I have. So this is not truly the graph, but that's going to be its shape. What I would say instead is it does this. And it continues to grow on your x-axis, making this ellipse shadow if you were to view it straight on the x-axis. So it's this shadow that'll keep spinning around as you go. Okay. Next one. Keep cruising. And if any of this seems like it's really difficult, I recommend graphing these like 3D. I'm sure there's some tools out there that you can graph 3D on the internet or something like that. It's just good to see, you know. But I'm going to keep moving. I'm not going to focus on that. So for this problem, I got two different points. It's a -1. So P and Q. And they're wanting a line segment. They say that. They say they want a line segment. It's kind of like a graph using r of t equals something or other. So I want to find out what that is. And this is actually a vector. So I want that vector. Basically, I have this. I want this part. I want that yet again. So how does this work? Let me give you a formula. That vector answer, I guess kind of like your line, is terminal minus initial times the t plus the initial. This will actually make a straight line, and we're going to do it for each one of these components. So simply put, here's your answer. So terminal minus initial, so I got 3 minus 1 t plus initial was a 1. That's my x component. So my y's, I got now a 6 minus a -1 t, and then plus a -1 again, comma. Last one, I got 1 minus the 3, so 1 minus the 3 t, and then plus the 3. And there we go. This is actually your answer. You don't need to simplify or anything, but if you really want to, it would look like 2t plus 1, 7t minus 1, and -2t plus 3. So there's your simplified answer if you want to do it that way. Keep moving. The next one's a graphing one. This one was kind of harder to view from one angle, so I'm going to probably draw it from different angles here. X is equal to t cosine of t, y is equal to t, and I got z is equal to t sine of t, and they're specifying that t's got to be positive, but it's not really a big part here. We're wanting to figure out how this works. Notice that this is increasing linearly increasing, so that's going to be important. Essentially, my y-axis, like as my t keeps going, I'm going to be also going on my y-axis and just progressing on it, okay? So that's easy. Notice that here and here they look kind of like a circle, but not really, because my amplitude is changing. Notice my amplitude is dependent on t. So it's kind of like a circle, but with the radius is continuing to change. So I want to say spiral, but it's more like a tornado kind of. So I want to just graph this. So I'm going to say, let me just write this down: an increasing radius. Okay, increasing radius. So how does this work? How does this look? So x, y, and z. Again, I'm going to be going along the y-axis, and I'm going to be circling around with this xz stuff. That's just a little hint on the side. X and z. Notice x is cosine, like typical. Y, I'm sorry, z. I mean, that's the point though. Z is sine, and so I'm saying it should be starting on the x and going counter clockwise. But again, my radius is changing, so what's going to happen is it's going to spiral out essentially. and then move along the y-axis. So here we go. My best attempt. Oh, you know what? I'm going to do a different color. My best attempt. Here we go. Nope. That did not work. Let me try again. Okay, does that help? Not much. I think that the view of this one, it doesn't help very much. So let me draw it from different angles, and maybe you can see it better. So here's another one. Let's say I've got X, Y, and Z. Again, what I want to do is go around this way. Let me use a different color. I want to go around this way. I'm getting bigger radius, and I'm also going towards the Y. So I'm going along the Y, and I'm getting a bigger radius as I keep going. Okay. Let me try one more time. I think that's pretty good. That's about what I have. So you should be seeing, ultimately, this radius here keeps increasing out. So your radius, maybe I didn't draw it perfectly, but the thing is your radius will keep getting bigger and bigger as you're going along as well. Okay. Another one. Honestly, you can just see that I'm trying to explain to you how this comes about, but really these are multiple choice, and, well, there you go. I got x is equal to cosine of 6t, y is equal to sine of 6t, and then z is equal to e to the 0.6t, and they say t has got to be greater than or equal to 0. That's whatever. Okay, so you can notice here what we have is a circle, for sure. That's a circle. I know that you have the 6 on the inside, but it just makes the circle go faster. It doesn't really do much, so I'm going to call this a fast circle. But it doesn't change the fact that its magnitude is a 1. So you're just going to be doing woo, 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 just a lot, instead of just like maybe slow arcs. It's a lot real fast. This guy right here is interesting because you're not growing, it's actually exponential decay. Well, actually, hold on. No, it's growth. Yeah, it's growth. Notice decay would have a negative number there. This is a positive, so although it's less than 1, it is still growth. It's just not as fast as I was thinking. So, yeah, it is exponential growth, but along the z-axis. So that's kind of weird. It's not linearly increasing. It's exponential growth increasing along that axis. So, here we go. Again, my best attempt at drawing this stuff. So the shadow that it's going to produce down here is always radius 1. So it's kind of like the shadow that you'll be seeing on the XY axes here, these guys. Oh man, that's terrible looking. Well, it's close enough. You get the idea. So I got a circle on the bottom, and then what's happening is that I'm going to be coming out from the circle. So growth, 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 and it'll keep going that way. I'm going to draw this a little bit better, honestly, because, yes, it's going up, it's increasing, but it's exponential growth increasing. So it is true that it's increasing. So let me just try again one more time. Sorry about that. Okay, X, Y, Z, and here we go. Going around a little slowly, and then it's going to exponential grow. Oh, trying again. Going around, and then it's still radius 1, but notice that it goes around a little bit more here at the beginning, and then its gap here, the gaps should be getting bigger and bigger as you keep going. So, just on the side, I guess, you can say it's kind of a lot, and then I just cannot do it very well with this little tablet. See, and then it's going to keep going bigger like that. There you go. These gaps between each period are getting bigger as you keep going. That's the idea. All right. You can see why I try to draw it multiple times to show you the angles and the understanding of it. 13040. I got an R is equal to sine of t, cosine of t, t. And they're wanting to know, when does this intersect the x squared plus y squared plus z squared equals 37. Well, this is strange here. What is this and what is that and what are they doing? Well, you notice this time I had a circle increasing linearly along the z-axis. So if I wanted to draw it just kind of real quick like, it's going to start here and it's going to go up the z like this, increasing linearly. So this is what I have right now. They're wanting to know where it's going to be touching this. What is this? This is a sphere, and it's literally a sphere. All of it's just radius of square root 37, which is a little bit. It's pretty close to 6. So we got this sphere going on here. No, I do not draw the best spheres, but that's okay. Essentially, I have this ball, this sphere here, and I'm wondering when this spiral is going to be touching it, when they intersect. Okay, so imagine that it's coming out and bursting out of the sphere in 2 places. Right here, it's bursting out of there, and then it's coming out. And then also, because this is going to keep going down, it's also down here bursting out. Okay, so we're going to see 2 answers. So how do you find them? Well, this is an x, a y, and a z. If you take those and you plug them in, you can start solving for t. So I've got sine of t squared, cosine of t squared is equal to 37. It's funny because sine and cosine together here, they make a 1. Literally, just 1. Always. Sine squared plus cosine squared is 1. So 1 plus t squared is equal to 37. Subtract the 1. 36. Square root. Plus or minus 6. Again, that's not what they're wanting for their answer, but it's very close. We take that and we plug it in to our r to find out my final answers as points, x, y, and z. And so their actual answers here are in the form of x, y, z, and then they have this in a big old box. And so I'm going to plug in the -6 and plug in the 6 and get my answers. So how it looks is sine -6, cosine -6, -6. Again, what am I plugging it into? Right there. Sine of 6, cosine of 6, 6. That's all I'm doing this whole time. Same thing for the other one. It'll just be sine of positive 6, cosine of positive 6, and then just the 6. So there's your second answer. Okay, next one. 131050. I have my R of t is an... Oh, my R of t is the intersection. I see now. It is the intersection of... And I have 2 things here. X squared plus y squared equals 36. Looks like a circle to me. And then we got this z equals x squared. Notice that they brought in a z. Without that z, I probably would have thought just 2 dimensions and stuff like that. But because they have a z, I've got to think 3-dimensionally. So this is no longer just a circle anymore. I mean, yeah, it's basically a circle. But I'd rather call it like a tube, or rather a cylinder. And so because there's no z, it's not that z is 0. It's that z could be anything. We can have any z. So basically I have a circle down here, and it extends up and down. It's a cylinder. So I have a cylinder on this side. Right here, this is kind of an odd one. What do I got? Oh, I didn't even draw it on my paper. I just said, oh, you just do the math. Well, anyways, I'm pretty sure this is a saddle. So it's a saddle. There's really no way for me to draw this properly. But you got a saddle, and there you go. So where the saddle is going to intersect this thing, there should be some kind of a graph. And so let me just rough it for you. It's basically kind of like a lumpy little circly thing, and it looks like it might wobble depending on your angle. But it's gonna be on that cylinder, but it's trying to follow that saddle. So how do I find that intersection then? So notice that I can start substituting stuff in for this stuff. Like if I have a circle and I know it's going to be a circle, if I view it down from the xy and I'm viewing the xy plane straight down on the z-axis, I'm going to see a circle because it's got to be on that cylinder. So how do I make a circle for x, y? It's pretty easy. We're just going backwards from what we've already learned. I'm going to say cosine t and sine t. Was there any kind of radius? Yes. My radius is a 6, so I put a 6 in the front of those. Try to make that look a little bit better. Hold on. Just a tiny bit better. Sine of t. So there's a 6 in the front because that's our radius for that. So this is an x and a y. I'm basically making a circle now. So how do I make that z component on this line? Well, I have a z. Do you see? It's x times y. And I have an x and I have a y. So I'm basically just going to be shoving that in right here. So here's my final answer. I'm saying I have a circle on the xy plane. And then here, I mean, not to be weird about it, but it's just x times y. I don't have to necessarily say, oh, let's construct a saddle of some kind or something. No, just, there you go. Cool. Unsimplified, but it still works. That's the answer. One last question in this section. Here we go. 131051. It says yet again that R is the intersection. Can't spell well, but you just heard me, so that should be good enough. I got z is equal to the square root of x squared plus y squared. And I also have z is equal to 6 plus y. Kind of strange there. This guy right here, if you move this over, you would get z squared by himself. I think that ends up being like a cone. So I'm pretty sure that's a cone. I'm not going to go into that. You don't really need to graph it, of course. This guy right here is definitely a plane of some kind because everything's it does not have a square in it there. It's all 1 powers. So I got a plane and a cone where they intersect, etc. So notice that z equals. You could literally then set them equal to one another like that and then start to solve. So first off, square both sides. Remember that when you square both sides, you do not need plus and minus. You do not need plus and minus. It's only when you square root both sides. Of course, you want to FOIL this guy out. So that's going to be 12y plus 36. And these guys cancel. When you subtract them on both sides, they cancel. So what you're left with is something kind of funny here. I'm wanting to get my answer in terms of one over the other. I recommend personally to get y equals because there's a single y. Pretty easy there. So minus the 36 divided by the 12. So x squared minus 36 and then all divided by 12. This is a very key part. I mean, if they want the intersection at all, there you go. This is where it should happen for y and x. Again, if we're looking down from the z axis, we can see that this shape essentially. And if you notice, it's just shifted down some, and then it's going to be a positive parabola going up. Well, that's neat. But now how do I actually answer it with my r, right? Well, it's kind of funny because I know what y is. So let me kind of just space them out. I know what y is. I can basically toss that in, but you can't use an x. You got to use t's all over the place, right? This is technically r of t. So how do you put that in? Well, you just say it's a t. Because you could just then say also that x equals a t. So if you just literally set x equal to t, you just say that, you just make it happen, then this guy makes it very simple. This is easy, very close to the end. The last one, notice that we have right here, either way, you can have z is equal to this or z equals equal to that. This one's much easier, and so I'm going to simply say 6 plus, and then y, I can't say y, I got to use t's, so I just replace whatever that y was. There you go. So again, that's z equals 6 plus y to get that answer. That's it. That's all I got. Thank you very much. Have a good day.